Today's chapter is household electricity. We call it domestic electricity, the electricity which we use at home. So it is all about that. It's quite an interesting chapter and quite practical based chapter, practical based. First of all, you should know which energy, there are various forms of energy. We have light energy, we got heat energy, we have solar energy, we got electrical energy, we have magnetic energy. So many forms of energy are there. Mechanical energy, there are two types, potential, kinetic. You must have come across with these various forms of energy, the chapter number 2, work power energy chapter. So which energy do you think is the most important or most desirable form of energy? Which type of energy is most desirable form of energy? The answer is electricity or electrical energy. Electrical energy is the most important form of energy, or most wanted or most desirable form of energy. Most desirable. You know what is the reason behind why it is most desirable? Because electrical energy can easily be converted into any other forms of energy. Other type of energy generally don't convert, or we can't convert into other various forms, but it is electrical energy which we can convert into various forms of energy. The things of convenience or comfort all are electrical, all are using electrical energy. I think you must have seen, we have been using it, like we got bulb, we have fans, we got TV, we got refrigerator, washing machine, heater, toasters. Most of the gadgets, most of the devices are electrical devices. They are, in most of them we are using electrical energy. Whatever we want, we can change electrical energy into that form of energy easily. That's why it is the most demanding or most desirable form of energy. That is electrical energy. That is the reason why every country makes most effort to generate electricity. The countries which are superpowers or which are developed countries, they have higher number of resources of electrical energy. So they generate electricity. Electricity is the such kind of energy, whenever you want and whichever form you want to use it, you can easily put into use. That is why it is called most desirable form of energy. Okay. Now, previous chapter also you have done the SI unit of any kind of energy, whether it is light energy, electrical energy, or sound energy, heat energy, any kind of energy, the SI unit is always joules. Same way, electrical energy's SI unit also will be joule. And its CGS unit will be erg, erg. And previous chapter you have done 1 joule makes 10 to the power of 7 ergs. That relation stands true here also in this chapter. 1 joule SI unit of electrical energy is joule, and its CGS unit is erg. 1 joule is equal to 10 to the power of 7 erg. Okay, just keep it in mind, this fact. Now, how do we measure electrical energy? Any kind of energy is measured by its work done capacity. Energy means the work done capacity. So you have to write down the definition of electrical energy. Electrical energy's definition and the formula. Electrical energy. Electrical energy denoted by the symbol capital E. Okay, please write down the definition. It is measured by the amount of work done. It is measured by the amount of work done to move a charge between two points in an electrical circuit. Therefore, we write down formula. Electrical energy E equal to, the formula will be charge multiplied by the voltage. Charge multiplied by the voltage QV, where Q is charge and V is voltage or potential difference, or PD, or we write as PD. So we have the formula E equal to QV. This is the basic formula, and from there we can change like this. We know since I is equal to Q upon T, current formula we have charge upon time. Therefore charge is Q, so Q value will come cross multiply will become IT. Therefore instead of Q we can write IT. Let us put the value here. I keep V as it is, and instead of Q I will be writing IT. So the formula of electrical energy becomes VIT. What is V? Voltage. What is I? Current. And what is T? Time. So electrical energy formula we have VIT. We can remember it this way. Electrical energy is very important for the time, for this time, for the present time. VIT. Like VIT is very important person. Same way VIT will be very important time. It is very valuable or very important for this time, for the present time. You can take it this way. Electrical energy formula is VIT. Okay. Further continuation, we write this E equal to, we know Ohm's law. V is equal to IR, just the previous chapter. Voltage is equal to current into resistance. The value of voltage I put IR. It becomes IR and IT remains as it is. IT I keep as it is. Ultimately I and I multiplies and become I square RT. This is another form of electrical energy, another way it is measured. This formula is used for heat produced. You can just mention here heat produced in resistance. Like whenever we are supplying heat, we are supplying electrical current in heater, in geyser, where we are making use of the heating effect, where the formula of energy become I square RT. R is the resistance and I is the current and T is the time. Actually one is derived from the other. One is coming from the other equation. Basic is this one. I put the value of Q, IT, it will become VIT. I put the value of V out here, it will become I square RT. Similarly, if you continue a little further, we write as E equal to, instead of I write V by R. Here, I equal to V by R. I write V by R square RT. This become cross one into squaring it, RT, R cancel, this becomes V squared by RT. This is also the formula of electrical energy. Now there are 1, 2, all the formulas I am putting into boxes here. There are 4 boxes, 1, 2, 3, 4. Now the question is which formula and when to use. This formula we use with charge and voltage given. Probably this formula will not come in Icse. Second formula, when to use, when we have voltage, current and time. These 3 things are given. The question when resistance is not given, we will be using this formula. Third formula we will use when voltage not given but current is given, resistance given and time given, or they are asking to find the heat produced in the resistance. Third formula we will use. And the fourth formula will be using when current is not known, only voltage and resistance is given. Then we can use this formula to find the value of electric energy. So these are the forms. If you know one formula, I suggest if you remember VIT, from there you can derive all the formula you can derive. You can add VIT, this IT value become Q, it become VQ. Second formula, instead of V you can put IR, it become I square RT. This formula you have to get in I value put V by R, V into V become V square by RT, you will get this. So basic formula is this one. If you remember this VIT, then we can express it in another form easily for yourself. Instead of IT I write Q, it become VQ or QV. QV and VQ is same thing. If I put the value of VIR, I will get this. If I put the value of I value will become V upon R, V by R, I will get this. So these are the formulas for measuring electrical energy. Now write down below the SI unit of electrical energy is As I told you in the beginning, the SI unit of electrical energy is joules. The SI unit of electrical energy is joules, and CGS unit is CGS unit is erg. You can write down the formula. 1 joule is equal to 10 to the power of 7 erg. I have told you already in the beginning, now you're writing it down. 1 joule is equal to 10 to the power of 7 erg. Okay. Now write down below this. This is the important part. Please write down the commercial unit. The commercial unit of electrical energy is kilowatt hour, kWh. Kilowatt hour. Full form is kilowatt hour. Kilowatt hour or BOT. Kilowatt hour or BOT is same thing. This is also known as Board of Trade unit. Board of Trade unit. Okay. Why we are calling it commercial unit? Because every month we consume electricity and we pay the bill, and the bill comes to our home and we have to make payment. Every houses or household has to pay the bill, and we pay the bill of electrical energy. Remember it, we pay the bill for consuming electrical energy in terms of kilowatt hour, not in terms of joules. 1 unit, we consume unit. In a month you may be consuming 300 units, maybe 400 units. Whatever units you consume, 1 unit is 1 kilowatt hour or 1 BOT. 2 kilowatt hour is 2 units. 3 kilowatt hour is 3 units. At home you must have seen a meter there. No? There is a meter at every home, I suppose. You can check the meter there. In the meter they have written kWh. Kilowatt hour is only written there in the meter. And there is a digital meter, so the digit goes on moving there, and you consume the electrical energy in terms of kilowatt hour. Like maybe 1, 2, 3, the digits are going around there, and then you take the reading there in terms of kilowatt hour. Okay, 1 year in ICC they had given this question, and you can also think. We pay electricity bill. We pay electricity bill for consuming what? What do we pay the bill for? For consuming electrical energy. Remember it. We don't pay the bill for consuming voltage or for consuming power or for consuming current. We don't pay the bill for that. We pay the bill for consuming electrical energy. Remember it. And that's why in terms of kilowatt hour, the rate is fixed according to the consumption in kilowatt hour. Present rate, it varies from place to place, but present rate in Kalimpong is nearly 6 rupees, approximately 6 rupees per kilowatt hour. That means 1 unit consumption charge is 6 rupees. If you consume 100 units, that means how much bill you have to pay? Or 100 kilowatt hour means 100 unit. How much will be your bill amount? It will be 6 multiplied by 100. That means 600 rupees is your monthly electricity bill. So that way you can count the amount of the bill which you get every month from the department, and you pay the bill. Okay. Now we'll see 1 kilowatt hour definition will write. Write on the definition of 1 kilowatt hour. Okay, write down. It is the actually kilowatt hour is actually what energy, no? Energy that we are measuring in terms of kilowatt hour. 1 kilowatt hour, write down. It is the amount of electrical energy. It is the amount of electrical energy consumed. It is the amount of electrical energy consumed by an appliance. When used when used for 1 hour. When used for 1 hour. Okay, once again, it is the amount of electrical energy consumed by an appliance of 1 kilowatt when used for 1 hour. Once again, I will tell you the definition. I think I might have missed out some part of it, so please write it down again. It is the amount of electrical energy consumed by an appliance of 1 kilowatt. Appliance of 1 kilowatt when used for 1 hour. When used for 1 hour time. 1 kilowatt. Kilowatt is coming from power, electrical power. So 1 kilowatt into 1 hour. When we multiply, then we get the answer 1 kilowatt hour. 1 kilo, instead of saying 1 kilowatt, we can say 1000 watt. That also will do. We can say it is the amount of electrical energy consumed by an appliance of 1000 watt. Instead of saying 1 kilowatt, we can say 1000 watt when used for 1 hour. So that is the definition of 1 kilowatt hour. Now we'll check its value in joule. What is its value? We write here 1 kilowatt hour will be equal to 1 kilowatt into 1 hour. 1 kilowatt into 1 hour, when you multiply, you get 1 kilowatt hour. 1 kilo means 1000. It will become 1000 watt. We are changing in SI unit. 1 hours we have to change in SI unit, that is time. Hour you have to change in seconds. How do we change at 60 into 60? 60 into 60. The answer will come 6 6 are 36 and 5 zeros will come here. 1 2 3 4 5 0. This one joule. We are changing the entire thing in terms of SI unit. That is coming 36 and 5 zeros. That is 3,60,000 joule. This thing we write in terms of scientific form like this. First we write 3.6 into 10 to the power. How many places we have brought back, that much will be the power of 10. Let us count. 1, 2, 3, 4, 5, 6 places we have brought back in order to put a decimal. Then we have to raise the power 6 joule. So 1 kilowatt hour. This is the important part. You may not have to show this unless question asks you to show this. 1 kilowatt hour makes 3.6 into 10 to the power of 6 joule. 10 to the power of 6 we can write, or we can write here like this. 1 kilowatt hour is equal to 3.6 mJ. Megajoule. Capital M is mega. Megajoule. MJ. So many people they learn it easy way. MJ is Michael Jackson. So they learn that way. So 3.6 megajoule. So remember it. 1 kilowatt hour is equal to how much in joules? We can write either this way or this way or this way. There are 3 modes. There are 3 ways you can write, and each one is correct. You get full marks for writing in either of these forms. In either of these forms. It is not compulsory that you have to write like this, or you have to write like this, or you have to write like this. In any one of the, but the most preferred form is this one. The most preferred form is this 3.6 into 10 to the power of 6. We can see a trick also. This is 6, power also coming 6. Why you are writing 3.6? Because you are changing hours into seconds. So 6 6 are 36 will come. Then you have to remember at exam time 36 is coming. So point you have to put here. And then this is 6. Raise the power 6. It is easy. If question comes this way, which physical quantity is measured? Which physical quantity is measured in terms of kilowatt hour? You will say that is kilowatt hour. You will say energy. Energy is measured in terms of kilowatt hour. Or if we can specifically mention electrical energy, is a better answer. Because electrical energy commercial unit is kilowatt hour. We pay the bill every month on the basis of consumption in terms of kilowatt hours. So kilowatt hour is the electrical energy. How is it related to its SI unit? Question comes. How is kilowatt hour related to its SI unit? Relation is you have to write formula between them. You can just write this one. 1 kilowatt hour is equal to 3.6 into 10 to the power of 6 joule. This relation you have to keep. If question comes, derive a relationship between kilowatt hour and joule, then you have to show the steps in that case. First you will be showing these, then this, and then this, and this, like this. You have to show the steps of derivation, how it comes. Probably they will not ask you that. They will ask you Which physical quantity is measured in terms of kilowatt hour? You say electrical energy. And how is it related to its SI unit derived from this answer? 3.6 into 10 power of 6 joule. So this is the definition of 1 kilowatt hour. And we are paying the electricity bill for consuming electrical energy, mind it. We're not consuming voltage, we're not consuming current, we're not consuming power, and not for anything else. We pay only for consuming energy, electrical energy. Okay. So this is about the topic energy, and then we are into the next part of it. Yes. Next thing, you must have seen many devices at home we are using where electrical energy is converted into the other forms of energy. I think in washing machine, what energy conversion takes place? We say electrical to mechanical. In electric fan, what energy conversion takes place? Electrical to mechanical. In heater, what energy conversion takes place? Electrical to heat. In toaster, also same, electrical to heat. In washing machine, what energy? Electrical to mechanical. In refrigerator, what energy conversion takes place? Electrical to heat. Heat is absorbed, that is causes cooling over there. So many devices we are having at home where we are using electrical energy. You can suggest your own also examples, or they may give some situation of there and you have to think and write down electrical energy is changing into which other form of energy you can write down yourself. Now the second topic you have to know is electrical power. Electrical power. Electrical power denoted by P, capital P. So write down the definition. It is the rate consumption of electrical energy. It is the rate of consumption of electrical energy. Write down formula. Therefore, electrical energy formula will have power upon time. Power is equal to electrical energy upon time. P is equal to E by T. Electrical power, any kind of power is what? Work upon time. And work is a kind of energy. See, with energy we do the work, so we like energy by the time. This formula we can take it this way, or let us say, or energy is equal to power into time. Because energy is equal to power into time. So this is also formula of electrical energy. Power multiplied by time will give the value of energy. If it is electrical power, we get electrical energy. That is what we do while we define 1 kilowatt hour. Kilowatt means power and hour means time. So power into time is making the energy. Okay, now let us continue with this like power. Energy formula we have. I gave you 3 formulas for energy. Look at the second formula of energy. Energy formula I gave VIT. So VIT by T, if you put that value VIT upon T, so TT cancel and power value will become VI. So this is the first formula. P equal to VY. Power is equal to V. First formula is here. Power is equal to energy by the time, or energy is equal to T into T, and here it comes power is equal to VI. Next formula, P equal to V is equal to IR will become I squared R. You can see the third formula over here. In the energy part, you see the third formula. I square RT, IRT by TT cancel the answer, left over will be I square R. Now next one you can write P is equal to V squared by R. These are the formulas of power. If you know the formula of energy, you know the formula of power. Or if you know the formula of power, you know the formula of energy. If power is equal to VI, then energy formula get PT. That is instead of P, we can put the value VI, become VIT. Second formula, I squared R is there. Then power is equal to E is equal to, instead of P, you can put I square R. I square RT, you get the next formula number 3 of energy. So we can learn that also. Energy equal to power into T value, put this one, V square by R, become V square by RT. So that is the formula of energy. So one is related to the other. Okay, now write down the SI unit of the SI unit of electrical power is watts denoted by capital watts. whereas whereas the other units are whereas the other units are whereas the other units are kilowatt, megawatt, gigawatt, etc. You can write on the value, like 1 kilowatt is equal to 10 to the power of 3 watt. 1 megawatt, mega means 10 to the power of 6, you can write 10 to the power of 6 watt. And 1 gigawatt is equal to 10 to the power of 9 watt. This one is used in electrical power plant. Electrical power factory, where we generate electricity. I think in Sikkim we have NHPC, you must have heard, even in Tista, in this one, Kalizora, we are having the dams, on the dams, there is a hydro power station is there. That is what we call electrical power plant. There we generate electrical power, and electrical power is generated in terms of megawatt. In the NHPC and all, they write out the project or their NHPC project of 450 megawatt, some generates higher 750 megawatt. You may have a question coming like this: name the unit in which the power is generated in a power plant. Name the unit in which generally power is generated in a power factory or in a power plant. The answer will be megawatts. In that sense, it becomes important. 1 kilo is 10 to the power of 3. 10 to the power of 3 is 1000. That is 1 kilowatt is equal to 1000 watt. So this is about the electrical power, and its SI unit is watts. There is no commercial unit for it. This SI unit is watts. And the formula I have given here. If you remember the formula of power, then multiply by T, you will get the value of energy. Or if you know the formula of energy, divided by T, you will get the formula for power. Okay, now sometimes they have been asking this one, and it's mentioned in the video syllabus also. Every electrical appliance, two things will be written compulsorily. Two things are always there. You will always find two things always will be written. One will be the value of power in terms of watt, and one will be the value of voltage. Two things will always be marked or will always be there in any appliance. You must have seen a bulb, electrical bulb. You must have seen that this bulb is there, and there is a filament here like this. Filament is there. This is electric bulb. Bulb is there. There is inside a filament there, and in the bulb they will be writing out there like this: 100 watt dash 250 volt. It will be written in this manner always. In every appliance you will find this kind of rating. In fridge also you will find this one. It varies. Some bulbs will be having 100 watts, some bulbs will be 60 watts, some will be 20 watts, some will be 40 watt. Tube light also will have a different rating. Some tube lights will be 40 watt. Nowadays they are using LED tube lights, LED bulbs. Their power value is low. They consume low power or low energy. So we are using nowadays the LED tubes of 18 watt, 20 watt. And what is the voltage supply for home? The voltage supply is actually 220 watt, but here the margin will be 250 volt. Little bit higher voltage it can be used for. If the voltage is more than 250 volt, the bulb will fuse, the bulb will damage. That's why they give this kind of rating. So, okay, so about this I will continue. The next day I will continue about this one, and then we will be doing the numerical problems on this. So, continuation will be the next day.